Okay, I'm sorry guys, good morning. Let's start right away. Everybody's there, right? Fine. So we have been seeing equilibrium and we have completed the first part as I told you, right? We'll just do a couple of problems, just 2 more or 3 more problems, and then we'll continue with ionic equilibrium. Is it okay, people? Right. Just give me a moment. Okay. So they have given this reaction. So I have okay, so they're given this reaction, right? And they are telling that, so basically, obviously, you have to heat this reaction, right, to get this product, right? And then what they're telling is after the reaction has reached equilibrium, the temperature now became 25 degrees Celsius, right? And they have given Kp value to be 36, right? And what they're asking is what is the partial pressure of CO2 in equilibrium? Okay, right? So they're given the reaction. Right now, they say that initially it was heated, and then the reaction, the temperature was cooled down to 25 degrees Celsius, and they're given the Kp value, and they're asking you to find the partial pressure of CO2 at equilibrium. Yes, go for it. There's a very little, not tricky question, but just that there's a small detail which you have to know, which you must be knowing, right? And if you just see that, your problem is set. It'll just going to be take 20 seconds or even say maybe 10 seconds for you to answer this question. Okay, the clue is, hope you remember, I told you a statement regarding active masses of pure solids and pure liquids, right? So whenever you see pure solids or pure liquids, what you have to do? What is the active mass value?
1.
Yeah, so basically you don't have to include them in the Kp or Kc equation, right? Okay, So you need to put only gases or aqueous solutions. Yes, any answers? So the the core of the problem lies in the temperature actually. Yes, any answers? This is not a tough problem, it's just a tricky problem, right? Okay, let me help you out. Anybody wants more time? Or anybody wants to tell me what went wrong? What exactly is the problem they faced? Because I know what problem you would have faced. You want to tell me what problem you faced while solving this problem?
So the partial pressure of water.
Ah, correct. That's the problem you would have faced. Fine. Okay, let me help you with that. Right. Fine. So if I write the Kp equation for this reaction, guys, right? So let me. I have space. I can write it here itself. No issues. So if I write the Kp equation, right now, what it will be? I have so basically this and this I don't have to include in the Kp equation because they are solids, right? So I have to only include gases. Okay, let me do that. So it is going to be partial pressure of CO2 squared into partial pressure of H2O, right? But when do you think H2O will be in gaseous state? At what temperature? Hmm? At what temperature water will be in gaseous state? I mean,
100
at least
degrees
out.
Celsius.
Yes, but what is the temperature given here? 25 degrees Celsius. So H2O would have been initially at gaseous phase, but when the temperature cooled down to 25 degrees Celsius, this actually is going to be in liquid phase. Okay, so what I'm trying to tell you is that you don't have to include this in the equation. That's it. So Kp value is 36. So what is the partial pressure of CO2 now? What is it? 6. Right? Guys, everybody understood what I did here? Right? H2O should have been in the equation, Kp equation. Right? But that would have happened if they didn't give you anything about the cooling down process. Right? But they have told that the temperature is not high. It's actually going to be only room temperature, 25 degrees Celsius. And I know at room temperature, water will be in liquid state, not gaseous state. Right? So in the Kp equation, the only thing which will come is the partial pressure of CO2. Right? And obviously Kp is equal to, I have a stoichiometric coefficient of 2, so it is partial pressure of CO2 squared, and they have given the Kp value 36. So root of 36 is 6. That's the answer to this question. Everybody understood? Yes?
Yes, sir.
Yes, sir.
Okay, good. One more question and then we'll wind up, people. Okay, next question. Okay, actually, it's better that I send it in the group. It's better, right, guys? Rather than me dictating. Let me switch on the light. Okay, there is my phone. Yeah. So, guys, look at their groups. There'll be a question coming. As I said in the group, my question number marked 11, and I also did a marking there. Right, it's question number 11 there in the picture. Yes. So the question says these following equilibrium are established, right? And the pressure was set up in all these cases to 1 atm, right? So they are given three reactions and they are given the equilibrium constants values and they want you to arrange them in some order, ascending order or descending order or any of the choices which they have given, right? What would be correct? So guys, ready to get the schedule? Any new schedule you got regarding classes, our classes?
Only the revision, the CBSE revision
Oh,
schedule. Sir.
not that. For crash course, for JE people, right? So I don't know whether you will. I mean, you will be getting it soon. So from Monday, right? You will have every day chemistry at 5 to 6:30, except for Tuesday and Wednesday. Instead of Tuesday and Wednesday, you will be having on Saturday and Sunday. Normal classes we have on, like how we have Saturday 7 o'clock, Sunday 10 o'clock, right? Other than that, you have Monday, Thursday, Friday. You will be having 5 to 6:30
In the
classes.
evening or in the morning, sir?
Yeah, in the morning 5 o'clock. Are you okay, madam?
So we
Right?
have school from next week onwards. So this maths and physics during the week also we have to ask sir 7 to 8:30 because we have physical school starting next week.
Oh, physical school starting next week. Okay. So if at all you go, when will you be back? I hope you will definitely be back by noon time, I suppose.
Definitely, I'm sure they won't keep us for lunch and all, sir.
That's what I'm telling. That's what. So you'll be back by evening. Sorry, you'll be back by noon time. So it wouldn't be a problem, I guess. But I don't know about other subjects. Other subjects have been planned, I think, in that time only. I know about chemistry, but I don't know about mathematics and physics. Anyways, you'll let to know. You will know that, right? If at all you have problems, please mention that there. They'll take care of it. Accordingly, only they'll put the schedule. If you are not there, what is the point in taking classes, right? Right. So anyways, let them know whatever it is. Right? Okay. Any questions, people? See, I mean, any answers, people? We didn't do any problem on Lee chart case principle, right? But actually, it is gonna be. Okay. Anyways, so we'll concentrate on this question. Any answers, people? Okay, fine. So I'll help you out. Fine. Let me write the reactions first. So I have first one.
Sir, I'm making a guess. It's none of these are answered.
Yes, correct. It is correct. How did he guess?
So my logic was KP for K1 it's concentration of CO2. For K2, it's concentration of NH4 into concentration of H2S. And then for K3, it's concentration of NH3 square into concentration of CO2. You can't really say anything with that, sir.
Yeah, like this with what you said. Okay, anyways, let me come to that. Okay, so let me write the reaction. So CaCO3 should be CO plus CO2 gas, right? Okay, so if you look at this people, right, this is okay, this is CO2 gas. So if I now please understand, right, the total pressure in all the cases is set up at 1 atm. That's the most important point in the question, right? That's the most important statement. All the cases, 1, 2, 3 cases, what is that? The total pressure is set up to 1 atm, right? So if I write my Kp equation, see, you have only one gas here, right? And obviously only that gas can have a pressure of 1 atm. There is no other gases here, right? So whatever the pressure is set up, that is going to be only because of gaseous molecules, and in this case there is only one gas, right? So can I say, if I write partial pressure of CO2 here, that will basically be equal to 1, right? Easy, right? It's all depends on what is the total pressure. Total pressure is 1 atm. So in this case there's only one gas, so that 1 atm will be exclusively possessed by the CO2, right? So obviously Kp will be equal to 1. Actually, that's the value. I can tell you the value right away, right? Anyways, for second reaction, I'll just directly write the Kp value, guys. So you have basically NH3, like I'm just writing the gases. So you would have had NH3, and they tell that they have H2S also, right? And you see that from the stoichiometry, 1 mole is to 1 mole, 1 is to 1 is the ratio between NH3 and H2S. So if at all the total pressure is 1 atm, can I say this would be 0.5 and this would be 0.5 atm, right? So now if I calculate my Kp, which will be equal to partial pressure of NH3 into partial pressure of H2S, that will be basically 0.5 into 0.5, which will be how much? 0.25, correct? It will be equal to 0.25. Now you see Kp is lesser than, this is 1, this is 0.25. Okay, now let me check the other one. So the next one is, I have 2 NH3s and I have 1 CO2. Okay, now again, total pressure is 1, right? So can I say this for NH3, it will be 2 by 3, and for this, it will be 1 by 3. Can I say that, right? So 2 by 3 is 0.6, correct? 0.66, and this would be 0.33, right? So if you calculate the Kp, right? So it will be basically 0.66 squared, because I have 2 NH3s, and into 0.33, right? Okay, right? Okay, so that would have been the case, and I want to know whether it will be lesser than 0.25 or greater than 0.25. 0.6 is squared, it will be, say if I give it as 0.6, 0.6 squared will be 0.36, 0.36 into 0.3 will become, I think, yeah, it will be greater than 0.25. Okay, this will be greater than 0.25. This, whatever the value you'll be getting, I'm just calculating approximately, right? So what should have been the correct answer? You see, K1 is greatest, right? No doubt about it. Then comes K2, sorry, not K2, K3, because you see it's greater than 0.25. So K3, then the least value would be for K2. Yes, guys, understood how I did the problem. It's all going to be based on the total pressure of, say, 1 atm, right? And you see what are the gas molecules there, and now it's all based on stoichiometry now. 1, in this case, exclusively for CO2. In this case, 50% of this, 50% of this. In this case, 2 by 3rd of this and 1 by 3rd of this. That's it, 1 atm. And you can calculate the Kp, and you can arrange them in whatever order you want. Okay, right? And guys, one last question. Like, we didn't do any problem on Lee chart list principle. That alone I'll do, and then we'll go for ionic equilibrium. Okay, one more question coming on your way. So the question came, it's the 22nd question, which is marked there. Right? So they have given 2SO2 plus O2 gives 2SO3. And they have, what is that? 188.3 kilojoules. What is that in the question?
Energy released.
Energy release. Can you tell me a correct technical term for that? Thermodynamics, if you use, what will you say that?
Enthalpy of.
Correct. It's the enthalpy. No. It's just not formation or all. Enthalpy of the overall reaction.
Oh, okay.
Right? Enthalpy of this reaction is 188.3, and they have given it's a positive value. Right? That means it is going to be what kind of reaction? Exothermic or endothermic?
Exothermic.
Yes. Right? So whenever you have a positive value, it is going to be exothermic. Right. Okay. Now you can tell me. I think you don't have to write anything for this. I think you can just discuss. Right. Now, yeah. So they're telling that what are the ways in which I'll be able to increase the number of moles of SO3 formed. That means they want the reaction to move more and more in the forward direction. That's what they mean, because SO3 is in the product side, right? So I want the reaction to move more and more in the forward direction. Okay. So tell me, what the first one? Temperature is increased at constant volume. Is it correct?
No, sir.
No, sir.
No. Yes, because it's an exothermic chemical reaction, right? If I increase the temperature, it is actually going to move in the backward direction. That is going to decrease the amount of SO3. So A is not the answer. Inert gas added to the mixture, and actually that is a very crude statement, right? They didn't tell anything about the constant volume or constant pressure. So again, we will come back to that later. Like if at all nothing holds good, then we'll see about it. Okay. Next, O2 is removed from the mixture. What do you think? This could be the answer.
No, sir.
No, right? If I remove reactants, the reflex of the reaction would be to produce more and more of the reactant. Correct. Whatever is removed, Lee-Chart-List principle. Whatever is removed, that has to be found again. So obviously, it has to move in the backward direction. Okay. Next, volume of the flask is decreased. What about this? What did I tell you for what? Tell me.
Yes, sir.
Yes, that could be the answer. Can you explain how?
Sir, I'm not too sure, but
Yeah, you can just try. No issues. Nobody is going to judge you. Please try.
okay,
Sir, it's gonna remain constant, right?
Which is going to remain constant, Kanna?
If the volume is decreased.
Okay, fine. So let us hear who was that answer who told D is the answer?
me, sir.
I mean, name. I'm not able to see the chats, right? Srivatsan. Yes, Srivatsan. So please tell me, how do you end up with the answer? Whatever it is, you can just tell me.
Sir, since it's an exothermic reaction,
Okay.
it is inversely proportional to temperature, correct, sir?
Inversely proportional to temperature. Okay, fine. I see. Okay, fine. Next.
So temperature is directly proportional to volume, something like that.
Okay, it's a little bit complex. Anyways, guys, what did I tell you? If I have, first of all, right, I think it was Harini who said that this is going to be constant, correct? Was it? Or it was,
Yes.
I don't know. Okay, Harini, why do you think it's constant, Kanna?
Sir, because heat is also considered as one of the products. So if we
Okay.
consider the number of moles on the reactant and the product side, it's 3 on both the sides. So it's going to remain constant.
How is it? Oh, you are considering. Oh God, guys. Anyways, that's a nice thing. This I never expected, right? Anyways, it's okay. So I don't know whether anybody understood what she said, right? So she said heat is also one of the products, right? So she says the delta N is equal to 0, right? Okay, a nice one, nice one. But Kanna, yeah, like it's good that you have this imagination, but still, this is not correct. Heat is like, even though I say heat, like that's how I taught you. Okay, anyways, so you should not consider it like that. Like heat is just a number. It's not in general cannot be considered as a product along with it. I just wanted to explain you that time. That's why I told it like this. Anyways, good, right? So anyways, now in this case, delta N is not equal to 0. Right, you cannot consider heat. I say, like, if that's the case, right, I can even a little more, I mean, bring in little more imagination, saying that will it be only 1 mole of heat or 2 mole of heat, right? So anyways, right. Okay, so it's just 2 SO3 in the product side. The product is 2 SO3, and in the reactant side I have 2 SO2 and O2, right? So delta N is not equal to 0. Yeah, if delta N is equal to 0, what you said was correct. Okay, fine. So now tell me, what happens when I have delta N not equal to 0 kind of reactions? If I increase the volume, what did I say you? How you should do it?
So
What
D is
did I
the
say?
answer then.
Yeah, what did I tell you? For
So if
increasing
volume is
volume.
increased, it
Hmm.
shifts to the side
Hmm.
where it has more number of stoichiometric coefficients.
Absolutely true, right? So if I increase the volume, the reaction will shift to a side where I have more stoichiometric coefficient. That is for volume increasing, right? But what they have given in the choice is volume decreasing. So that means we're going to go to a side where I have lesser stoichiometric coefficient. So you see from the reaction, I have total stoichiometric coefficient on the product side is 2, in the reactant side it's 3. Okay, so obviously if I had to increase the volume, then backward reaction. Now in this case, I'm decreasing the volume, so forward direction. So D is the answer. Okay, good, right, fine. So that's it, guys. We'll stop with the problem solving. Right, I think we have solved enough number of problems in equilibrium. We'll move on. We'll move on to ionic equilibrium. Right. So then, like when this thing happened, there was this when I was teaching on my college days. I was actually teaching surface chemistry to, I think, someone of, I don't know which year was it. So anyways, there was a batch I was teaching surface chemistry. So I'm teaching about catalysis, and then I told them that like catalyst basically provides a surface for the reaction to happen, right? And there was this student who asked me this, sir. A cooking pan or a cooker, can it be considered a catalyst? I was like, what? Like out of nowhere, what are you asking? And he said, like, sir, yeah, that provides surface for us to cook. Cooking is also a chemical reaction. I was like, yes. So students is like I was not able to come up with an answer for that, right? So yeah, so like, see, that's what I'm telling you. Don't have to actually what to say, think that that is going to be a stupid question, that is not a good question, all those things doesn't matter at all, right? So again, this I'll remember for the rest of my life, Harini, right? Okay, anyways, nice. So we'll move on. Okay, so ionic equilibrium. Okay, so as you all know, you would have already studied the chapter. You know what we are going to study here. It is predominantly going to be about pH calculations, strength of the acid, strength of the bases. All these not qualitatively but quantitatively, right? We are going to provide numbers for all these strengths, pH, and all these things, right? Okay. So moving on. So as we already know, there are going to be 3 different ways by which you will be able to define an acid or a base, right? So can you tell me what are the 3 theories? 3 theories of acids and bases. At least one you can tell me.
Lewis, Bronsted, and then
No. Lewis is one theory. That is, next one is Bronsted. Okay, that is Lowry Bronsted theory. Okay, two. Then one more.
Arrhenius.
Yes, Arrhenius. Right. So all these three, I don't think I have to teach it. Okay, what does Arrhenius theory says? Arrhenius is the basic of all. What it says?
Anything that produces a H plus ion when.
Okay, that's what it says. That's what it says. But you should not say anything that produces H plus. Though there is one phrase which is missing. Anything which is dissolved in water, and if it gives me H plus, that is called a acid. Okay, so this dissolving in water is a very important point. Like say when I have HCl gas, this is not an acid. No, right? Because this cannot give me H plus. But if this is dissolved in water, then it will give me H plus, right? Then that's why that only then I can call it as an acid. Same way, if it's a base, when it dissolved in water, right, then it gives me OH minus, that's called a base, right? That's about Arrhenius theory. That's the basic, right? That you would have been studying from your, I don't know, whatever classes, 7th or 8th or whatever it is, right? Okay, so the next one is say Lowry Bronsted. We'll see what is this Lowry Bronsted. Now, why are you even going for this Lowry Bronsted is because we, like, now that you have learned little amount of chemistry, you know that there, like, H plus giving is not the only criteria. There are acids, right? There are acids which doesn't give me H plus, but still are considered to be acidic in nature, right? So for those reasons, we'll be going for the next two theories, that is Lowry Bronsted theory and Lewis theory. Okay, so what Lowry Bronsted says, okay, is that he talks in terms of protons. Okay, so what he says is anything which is capable of giving me a proton, right, is called an acid, right? I know what is a proton. Proton is basically H plus. Hydrogen has one electron, right? Now, if it becomes H plus, the one electron is lost. I would only have one proton in this particular species, H plus, right? So anything which gives me a proton is an acid. Anything which accepts a proton is a base, right? So there is not much difference between the acidic definitions between Arrhenius theory and Lowry Bronsted theory, but a new definition comes for bases, right? Say, for example, I want to define how ammonia is a base, right? So ammonia is actually capable of accepting this H plus to form NH4 plus. Right, so it actually gives a new definition for a base, because according to Arrhenius, whichever gives me OH minus, that's only is a base, right? But other way of seeing it, whichever is able to accept H plus can also be called as a base, right? That is called as Lowry Bronsted acid. It is not going to give me any extra definition for acids, but yeah, it gives some good insight about bases, Lowry Bronsted bases, whichever is able to accept a proton. Okay, next, last one that we have already seen in chemical bonding, right? Lewis theory. Anybody wants to comment? What is an acid? What is a base?
Electron pair donors are bases and electron pair acceptors are acids.
Yes, good, right? So whenever lone pair can be donated from a species, that is called a Lewis base, and same way whenever it can be accepted is called a Lewis acid, right? So example of Lewis acid can be BH3, BF3, BeCl2. All these things can accept a pair of electron because I know there are empty orbitals still left, right? Okay, and examples for this thing can be NH3, PCl3, right? Even PH3. All these things which has lone pair on them, which can be donated, right? Okay, so that is about Lewis theory. So these three theories, just I wanted to just make you a quick refresh, right? Fine. Now, guys, right now we are going to speak about the pH, the acidic strength, basic strengths, and all that, right? So, but what we really, how to put it, right? So for any of these calculations, not only for this, for any calculation for that matter, for any measurement for that matter, right, we require actually something called as reference points. Okay, so for example, I don't know whether you know it, the story of temperature, right? A story of temperature. How is it that what to say, water's boiling point is 0 degrees, sorry, not boiling point, freezing point is 0 degrees, boiling point is 100 degrees, right? All these are actually arbitrary values, right? So there was this guy called Celsius, right? So he just took 2 reference points. That's it, right? 2 reference points, 0 degrees, 100 degrees, freezing point, boiling point, and anything in between was scaled down, graduated, like in the sense that anything, say for like, I hope you understand what I'm trying to say, right? 2 reference points he took, and between that he made a scale, right? That became a Celsius scale. Okay, so for any measurement, for any this thing, you need to have reference points. Okay, so here in our acidic strength, basic strength, water is going to be my reference point. Okay, now we'll see how is it that water is going to have a reference point. Okay, and I want to tell you one more thing, guys. See, the way I specified that when I go for this Arrhenius theory, I said that whenever something is dissolved in water, right, now that only is going to be called as an acid, or the base is going to give me OH minus, right? Now, like generally how we write reactions like this, we write it like HCl or H2SO4 is going to give me H plus what is it, Cl minus, right? Now I would say this is not a correct way of writing it. And like even if you put water, like even if you like, generally people doesn't mention anything in the reaction, they just tell H plus gives, I mean H plus plus Cl minus, right? But what you have to understand is, guys, I understand that HCl is capable of giving me a proton. I mean, it is capable of giving me a H plus, right? But this H plus cannot be staying in the solution as such. It is very unstable. Okay. Now, what I have to understand is, if there is something that is capable of giving me H plus, right, there should be something along with that to accept the H plus. Okay, there should be something along with the HCl in the mixture, so that it will be able to accept the H plus, right? And that accepting H plus process or the work is done by the water molecule, right? But if at all you have, say, a neutralization reaction happening, right, so in that case it's the base which will accept the H plus, right? But without nothing, if you just have HCl even in liquid form without any water, right, it is actually not going to give me H plus. Okay, so there should be something in the mixture which will be able to accept the H plus. Only then the reaction moves forward, because this H plus is not a stable species. Now, how should I write the reaction then? Right, this is how you write the reaction. HCl, right? HCl. Obviously, I have to whatever the acceptor you want to put, you can put. Say I put H2O. Right, now what happens now, this is going to donate H plus, and this is going to be a H plus acceptor, right? So if this accepts H plus from here, what will happen? This will become your hydronium ion, right? And obviously what will be remaining is Cl minus, right? This is the correct way of writing the reaction. Not reaction, I would say the dissociation process. Okay, this is how you write it. But again, for our convenience purposes, we actually write it in the first way, but that is not exactly correct, because as I told you, for the reasons. Right, so you should have something to accept the H plus. Okay, right? So even if it's going to be a base, even if you put a base like ammonia or say NaOH, right? NaOH. Now what is going to happen? This OH minus is going to accept the H plus to form H2O. That's what would have happened, right? And this Na plus and Cl minus would have combined to form NaCl. Okay, so there should be something in the medium so that you'll be able to accept the H plus. That's what is more important. Okay, so as this is a very small point I want to tell you. So as I was telling, H2O is going to be my reference point. Okay, now why I took H2O as a reference point is because it is bear with my handwriting, people, because it is amphiprotic, right? So what do you mean? It's not amphoteric. Amphoteric is different. Amphoteric oxides can behave as acids as well as bases. No. It can react with acids as well as bases. It is amphoteric, right? And if it is amphiprotic, it will be able to accept H plus as well as donate H plus in the way that it will be able to behave as an acid or a base. That's what is more important. Okay, there is a difference between amphoteric and amphiprotic. Okay, fine. So how is it able to do that? Right, fine. Now, if I have only water, right? If I have only water with me, I would say this reaction will be continuously happening. If I take just 2 moles of H2O, right? Now, actually, if at all you didn't, if I didn't tell you, mention the previous one, that is, if there is a H plus donor, there should be a H plus acceptor. I can easily write the reaction like this itself, H plus OH minus, but this is absolutely wrong, right? Now, how should I write the reaction? The way which I'm writing at the top, that's how you must write the reaction, right? Anyways, so this, you should not write it like this. Okay, right. So this H2O, one molecule of H2O is going to act as H plus donor. The other molecule of H plus is going to act as H plus acceptor, right? Okay. So now if this gives me H plus to this, right? So what will happen to this molecule? This molecule will give me H3O plus, right? And this molecule has lost a H plus. So what will be remaining? OH minus will be remaining. Okay, so this is how you must write the reaction. Hydronium ion is stable. H3O plus ion is little stable, right? Okay, so this gives me H plus here. So this will become H3O plus, and this has lost H plus. So this would have become OH minus, right? So now if I write the equilibrium constant for this reaction, people, say K, and let me put a special word. Let it call KW because it's for water. Okay, so now that would be H3O plus concentration into OH minus concentration, right? Okay, now at 25 degrees Celsius, people, right, this KW value was experimentally found out. Don't ask me how. It's beyond the scope of your 12th, right? So this KW value was experimentally found out at 25 degrees Celsius, and they found the value to be 10 to the power minus 14. Okay, 10 to the power minus 14. Okay, now if that's the case, if its value is 10 to the power minus 14, now what I see from stoichiometry is that H3O plus concentration and the OH minus concentration should be same because it is 1:1 ratio, correct? So can I say if this KW value is 10 to the power minus 14, this H3O plus concentration would have been 10 to the power minus 7 and the OH minus concentration would have been 10 to the power minus 7, right? Okay, fine. Now this is the reference point. Actually, from this I think you'll be able to understand what I'm trying to do. So I have my pH calculations. Hope you remember the formula for pH. It's negative log of, generally they say H plus, but it's more correctly H3O plus. Right, the negative log of H3O plus concentration. Now, if that's the case, what you see is negative log of, if I take this particular case, it is basically going to be 10 to the power minus 7, right? So log of 10 to the power minus log of 10 to the power minus 7. Hope you know the log calculations, people. It is going to be 7. This is my reference point. Okay, so I say pH of water at 25 degrees Celsius is 7, and that is neutral because you know the H plus concentration and the OH minus concentrations are same, right? But if at all there is a species which can increase this concentration, that will have a pH less than 7, right? Or if there is a species in the mixture along with water which can increase this concentration, the OH minus concentration, then the pH will be increasing, and that will give me pH to be greater than 7. Okay, so this is how all the reference points were created, right? So KW, this value you have to remember, people, lot of times you'll be using this 10 to the power minus 14. Not only here, lot of times you'll be using this. Okay, you have to remember the value, right? And the pH formula, obviously. And I even have something called as POH, guys. I don't know whether you know it. I have, just like I have pH, I have POH, which is nothing but negative log of concentration of OH minus ions, right? That is also a formula you can remember. Okay, POH is negative log of concentration of OH minus ions. Okay, right? Fine. So now let us move on, right? And guys, in our syllabus, right, and not like in this ionic equilibrium, we are going to study about acids and bases, but actually we'll be studying about weak acids and weak bases only. Weak acids or weak bases. Now there is a reason for this, right? Now what is the reason? Say for example, if I take any strong acid like HCl, I'm writing the reaction which I said is wrong just for the convenience purposes, guys. Okay, so HCl gives me H plus plus Cl minus. Now what happens is, if it's a strong acid, right, I would say, but how do you generally say strong acids? Almost they are 100% dissociated, isn't it? So if I start with some 10 ml of HCl, right, now all the 10 ml ideally would give me H plus and Cl minus, right? So at the end of the process, if you see, the concentration of HCl would have become 0. Okay, again, if I want to do any calculation, my equilibrium constant, all these things, again, there's going to be a problem because I'm going to end up with a 0 at some point of the reaction, right? The same thing which happened in my irreversible reactions. If you remember in equilibrium, I told you we are going to deal only with reversible reactions. Why? Because in irreversible reactions, at some point of time, the reactant or product would have become 0. Reactant would have become 0. Spontaneous processes, and that is the reason why we didn't take any irreversible reaction for equilibrium. And the same things here. This is also an irreversible process, right? Okay, so remember that we are going to deal only with weak acids or weak bases. Okay, now if at all a strong acid is given to you, right? Say now if I give you say 10 to the say 2m HCl, if I give you, right, and I ask you to find what is the pH. Right now, you directly put the H plus concentration directly as 2, because this is a strong acid, and you see 1 mole of the acid will give me 1 mole of H plus, right? So whatever is the concentration of the acid, that itself you will be able to put it as the H plus concentration. It will be negative log of 2. Okay, am I doing it correctly? Yeah, so it will be negative log of 2. But if I give you 2m CH3COOH, you cannot do like this, because I don't know, it is not going to be 100% associated. It is actually going to be say 60% or 70%, right? Depending on that, what will be the concentration of H plus coming from this will not be exactly same as 2 for sure. 100% sure that this will not be 2. It will definitely be lesser than 2. How much less, that we'll see later. That we'll see now. Okay, right. Now there is one more thing I want to tell you. If say I gave you this question and I ask you, say I have a 10 to the power minus 8 hem HCl solution with me, right? Can you tell me what is the pH of this? I have 10 to the power minus 8 m HCl.
8, sir.
Okay, right. So it is, if you do the calculation, it is basically going to be 8. But how is it possible, guys? This is an acid and this is having a pH of 8. Doesn't make sense, right? So what are we doing wrong? Any idea how to correct this? Are we missing something here? It could be a guess. What do you guess? What are we doing wrong?
So 10 power minus 8 is the concentration of HCl and not H plus, sir.
No. So that logic is perfectly holding good, right? It's a strong acid. Whatever is the concentration of acid, that will be the concentration of H plus, right? But what we are missing here is, you see, this is a very dilute solution. 10 to the power minus 8 m HCl is a very, very, very dilute solution, right? So what happens is, in previous cases also, right? In the previous cases also, if I have, now in this case, it's a concentrated solution. Right now, please understand, guys, this is a HCl solution, aqueous solution, right? So it will contain HCl as well as H2O, correct? Right now, this is capable of giving me H plus. This is also capable of giving me H plus, but compared to HCl, this value is going to be pretty less. Can you tell me what is the value from water? How much HCl percent? I mean, what is the concentration of H plus I will get? Just now we saw. What is it? What is it?
10 power minus 7.
Absolutely. It will be 10 to the power minus 7. Right? So just now we saw Kw was 10 to the power minus 14. So water, H plus concentration from water would have been 10 to the power minus 7. Right? But compared to 2, 10 to the power minus 7 is very less. That's why we neglect it. We don't consider this. Right? But if in this case, this is 10 to the power minus 8 HCl, so it obviously 10 to the power minus 7H plus coming from water cannot be neglected. This is 10 to the power minus 8. Water is giving me 10 to the power minus 7. Now, last case, you are able to neglect because this value is very small, right? But the H plus concentration itself from H itself is very small. So you cannot neglect the H plus coming from water in this case. You have to add that. Okay. Now, if you do the calculations properly, people, right? So my pH would have been negative log of 10 to the, 10 to the power minus 8 plus 10 to the power minus 7. That's how you must do it. Now, if you calculate, it will be around 6.97 or something. Now it's lesser than 7. Then it's good. Acid means it should be lesser than 7. Okay. So there are I have seen there are almost like so many years question paper. If you see JEE mains question paper, this question would have been there. And in the options, they would have had an option C or B to be 8. So if you had marked it, -1. Okay, so please be very careful. So whenever you see the H plus or the acid concentration is lesser than 10 to the power minus 7, even if it is equal, right? If it is lesser than or equal to 10 to the power minus 7, then you have to include the H plus concentration coming from water also. Okay, please keep this in mind. Okay, fine. So this is about the strong acid part, right? Directly, whatever is the acid concentration, take it as H plus unless and until this is happening. That is the acid concentration is lesser than 10 to the power minus 7. And you have to include water's H plus also. Okay, so now we'll move on to weak acids. What is the time? Okay. Now we'll move on to weak acids. Okay, so now weak acids, as I told you, I am not going to have 100% dissociation happening. Okay, right? So let me take any acid. Let me take a weak monobasic acid, HA, right? HA is a weak monobasic acid, some random acid I'm taking, right? This A can be any anion, depending on what kind of acid it is, right? Say now it is going to give me H plus A minus, right? Okay, now assume that say I start with some 1 mole of this. Okay, so it would have been 0 and 0. Right now, there should have been something reacted, isn't it? That is my alpha. Right, there would have been some amount of acid would have got dissociated. Now, if it was a strong acid, this alpha would have been 1. Right, I'm talking about this is a time t is equal to 0. This is at equilibrium. Okay, so 1 minus alpha. So what would have come here? Alpha and alpha. Right now, this alpha, guys, what is it called? What is it called as?
Dissociation constant.
No, dissociation constant is you're going to see. What is this alpha?
Degree of dissociation.
Ah, yes, it's called degree of dissociation. Okay, it's called degree of dissociation. How much dissociation is happening is determined by this alpha. Okay, now this alpha value can only be between 0 and 1. 0 means no dissociation, 0% dissociation, 1 means 100% dissociation. Right, so it's like if I just multiply alpha value into 100, so alpha value into 100, right, you will be getting percentage dissociation. Please remember that. Okay, alpha value is like just like scaling down from 0 to 100 to 0 to 1. That's what it is. Okay, fine. So anyways, now this you did for 1 mole or say 1 m of the acid. Now, if at all it was not 1, it was some other concentration. Say it was some C. I just multiply this by C, some other concentration. Everywhere I multiply by C. So this into C, this into C, this into C. Okay, fine. Now let me write whatever you're telling. Someone was telling acid, the dissociation constant, and that's what we are going to see now. Oops. Right. So the dissociation constant, if I see, that is what is called as Ka. Ka is called dissociation constant of the acid. Right. Now that if I write in terms of the C and alpha, you have C alpha will become C squared alpha squared. Right. Or if I write it properly, it will be H plus concentration into A minus concentration divided by HA's concentration, and that would have been C alpha into C alpha divided by C into 1 minus alpha. Right, so I can cancel one of the C's, so it is going to become C alpha squared divided by 1 minus alpha, and this is a famous equation which you should be remembering by this time, right? So Ka is equal to C alpha squared divided by 1 minus alpha. Okay, now but I'll be able to little what is that, simplify this equation. Right now, that is what is called as Oswald's dilution law. But again, I don't want to specify the names. It's pretty simple. If the alpha value, okay, let me go here. So if the alpha value is very, very less than 1, and if the alpha value is very much lesser than 1, now how can I write this? Is Ka, I can directly write it as C alpha squared. And 90% of times you will be using only this equation and not this equation, because that is easier for our calculation purposes. Okay, so mostly you will be using only this equation. Ka is equal to C alpha squared. Acid dissolution constant is equal to, the C is the concentration of the acid, right? And alpha is the degree of dissolution, that we know. Okay, and you can do a lot of stuff from this, right? So if at all alpha value you have to find, you can easily see that alpha is equal to root of Ka by C. Okay, alpha value is root of Ka by C. Right, now from this I can directly calculate the pH. Right, now you see guys, from the equation you see the concentration of H plus is this alpha, C alpha, right? The concentration of H plus is C alpha. So it basically pH would be negative log of concentration of H plus, and that would be negative log of C into alpha. That's what I mentioned there, right? So either you can use this directly to find the pH, right? Or if at all you don't know alpha or they have given you Ka, you can use this one and then find whatever is required and substitute it there. Okay, so this equation, so 3 equations. So this is the first one, this is the second one, and this is the third one. pH is equal to negative log of C alpha. These 3 things you remember. Law, it will be very, 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 very useful in the problem solving. Okay, so that is about acids, right? So then same thing I can speak about the bases also, right? Now exactly same thing. Say if I had AOH. Oh, wait. Before this, I want to tell you one thing, right? So we started all this to see the strength of the acids, isn't it? So please understand, the strength of an acid is directly proportional to the Ka value. More and more is the Ka value, more and more is the strength of the acid. But I have something called as pKa, right? The moment you see this P, guys, pH, POH, something like that, pKb, pKa, all these things. So this P is nothing but you have to include a negative log before the whatever the term you have. pH means negative log of H plus. POH means negative log of OH minus. So in this case, it is just negative log of Ka is what is my pKa. Okay, and what you have to understand is pKa and strength of the acid are inversely related. I think this you must have already known. We have solved some problems in organic chemistry, right? So pKa, strength of the acid is directly proportional to Ka, but pKa is inversely proportional to strength. Please remember that. Okay, right. So now you can move on to bases. Same thing, exactly same thing, but I'm not going to spend time. I'm just going to write the reaction. So it will give me A plus OH minus, right? So again, you will write Kb. In this case, it's a base. So it's called base dissociation constant. Again, everything will be same. C alpha squared divided by 1 minus alpha. Again, I'll be able to little say simplify it to just Kb is equal to C alpha squared. So now if I want, now I cannot find pH. I can find POH. Now that will be negative log of concentration, negative log of C alpha. Again, C alpha will be the concentration of OH minus. You will see this would have been C alpha. the concentration of OH minus, right? And hope you remember what is the relationship between pH and POH. Anybody remembers what is the relationship? pH
pH,
and
POH is equal to 14.
Yes, right. So pH plus POH is equal to 14. So, and mostly guys, you will not be asked to calculate, I mean, and the answer wise, I'm telling, the choice or the answers will not be in terms of POH. It will always be in terms of pH only, right? So after you calculate POH, then you calculate pH from this equation. pH plus POH is equal to 14. Okay, right? Fine. So that's about the base, right? So we studied about weak acids, we studied about weak bases. Now, next thing we'll see is about the salts. Okay. Any questions, people? Any questions you want to ask? I think I little went fast because like assuming that you would have little known here and there, but I've covered everything. I didn't miss anything. Don't worry. Any questions?
Sir,
Yeah.
that K is only for weak acids, right?
Yes. Ka is only for weak acids. And Kb is only for weak bases. We cannot talk about Ka. If okay, you tell me what will be the Ka value of no. Okay, you tell me what will be the Ka value of a strong acid?
Sir, infinity.
Absolutely. Right. So Ka value of a strong acid will be infinity. That's why we're not calculating that. Okay. Right. Fine. Good. So yeah, we'll move on to salts. Okay. So when I go for salts, right? So I know I have different types of salts, isn't it? Okay, so I have acidic salts, basic salts, neutral salts, and obviously last one is amphoteric salts. Right? Okay, so amphoteric, we know what is that, which will be able to react with acids as well as bases, right? Acidic, basic, neutral, we know how they are getting formed also. It depends on, obviously we know salts are getting formed with the neutralization reaction, acid plus base, right? So depending on what is the strength of the acid and depending on what is the strength of the base, I'll be able to get different types of acid, right? Say for example, if I take acetic acid, it'll be actually, sorry, not acetic acid. If it is an acidic salt, right? So I should have used a strong acid and a weak base. Only then I would have got an acidic salt, right? The same way, if I had a basic salt, then it would have been a weak acid plus a strong base, right? And neutral salts, I can visualize in two ways, right? So one can be a strong acid plus a strong base. This is more probable. Obviously, this is more frequent, and very rarely you can even have a weak acid plus a weak base. But this is the salt form will be really unstable, right? So, but yeah, there are cases which are reported by this also. But again, we don't have to worry about it, right? So strong acid, strong base, neutral salt, weak acid plus strong base, basic salt. Again, don't mug up anything. It's pretty logical. And when you have acidic salt, it should be a strong acid plus weak base. Okay, now in the question, guys, we are going to solve numericals in this, obviously. And in the questions, they will not give you whether it's an acidic or basic salt. You have to understand from the cation and from the anion. If you look into it, right, you will be able to understand what kind of acid I used and what kind of base I used. And accordingly, you have to decide whether it's an acidic salt or basic salt, right? For example, if I give you NH4Cl, now tell me whether it's an acidic salt or basic salt.
Acidic salt?
Yes. How did he say?
NH4 plus and Cl minus.
Okay. What would have been the acid? What would have been the base?
NH4 plus acid.
NH4 plus? No. This is a salt, right? Now this salt would have been formed from an acid and a base. What would have been the acid and the base?
And HCl.
Exactly. Right. It would have been NH4OH, which is a weak base, and this Cl minus would have come from HCl, strong acid. So definitely it would have been an acidic salt. Hope you remember, hope you understand what I'm trying to say. Same way, if I give you CH3, oops, that H became so elongated. Okay, so when I have CH3COO Na, now tell me what kind of salt it is.
Basic.
Basic.
Yes, so obviously you would have understood now. CH3COO minus would have come from acetic acid, and Na plus would have come from NaOH. CH3COOH is the weak acid, NaOH is a strong base. So this would have been a basic salt, right? So in the question, they will never give you, guys, please understand, right? So they will never give you, say one more example I'll give you. I have NaCN, acidic or basic?
Neutral.
Why?
NaCN. Okay.
NaCN. What salt?
Basic.
Yes, it is basic. Na plus would have come from NaOH. Cn minus would have come from
HCN.
HCN.
HCN. Yeah, that's it. HCN is a very weak acid. Okay, so NaOH and HCN would have formed NaCN. So it would have been a basic salt again. Okay, so like this only they'll give you. They'll not mention what type of salt it is. They'll just give you the salt. And you have to know what kind of salt it is. Right? And if you don't know, it is just going to be a formula application. Easy 4 marks you'll lose just because you don't know what kind of salt it is. Okay, fine. So move on. What is the time? Okay, we have time. Okay, so let me start with, say, an acidic salt. Like basically what we are doing here is basically calculating the pH of the acidic and basic salts. That's what you're trying to do. Okay, right? If it's a neutral salt, I know what will be the pH, isn't it? 7, and at least close to 7, right? But acidic or basic salts will have pH lesser than 7, and basic salts will have pH greater than 7. Okay, so acidic salts. Now, what I have to understand is, people, basically, I am talking about salt hydrolysis. Right, I'm talking about salt hydrolysis. Basically, what I mean by hydrolysis is just putting the salt, dissolving it in water, and then only I can study about the pH, isn't it? Right? I cannot. If I have a solid salt, how will you measure the pH? You cannot do anything, right? So you have to put the salt in water. That is what is called as hydrolysis. Dissolve it, right? Then you can take up the salt solution. Then you can check the pH. Okay, right. Now what you have to understand is, guys, whether it's going to be an acidic salt or the basic salt. Now please understand one point. It is the weaker component which gets hydrolyzed. Okay, it is the weaker component which gets hydrolyzed. What do you mean by this? I'll tell you. Say I'll take an example. Say I take this is an acidic salt. Okay, I'll take acidic salt NH4Cl, what we took there. Okay, now what do you mean? What do I mean by this weaker part? Weaker part in the sense you would have had acid and a base. One of them would have been weaker, right? So you have to take the cation or anion which came from the weaker part, right? Now in this case, Cl minus came from HCl. No, you are not taking that. But NH4 plus would have come from NH4. That's a weaker part, right? So in this case, weaker part is my NH4 plus. Okay, so this NH4 plus only you will write the hydrolysis reaction. So this NH4 plus reacts with water, right? Okay, now NH4OH would have been a base. So NH4 plus would have been a, what do you call? NH4OH is the base. NH4 plus will be dash of NH4OH. Again, I repeat the question. NH4OH is a base. Okay. NH4 plus will be called dash of NH4OH. What is a dash?
Conjugate
base.
Conjugate?
Acid.
Conjugate acid. Already NH4OH is a base, right? So after removing OH minus, what is remaining is NH4OH. So this is called as the conjugate acid of the base. So basically, this is going to behave as an acid. That's what I'm trying to tell you. That means it is going to donate H plus to H2O. right? So how will you write the reaction? It will be NH3, right? If NH4 loses H plus, this will become NH3, and this would have accepted H plus. So I would have formed H3O plus. That's it. Okay, so if at all, like this kind of questions can also come, they'll just give you the salt, and there can be 4 choices of writing the what is that, hydrolysis reaction. That can also be a question. So always you have to remember, it's the weaker component. Weaker component in the sense there would have been a strong acid, or say there would have been acid and a base. One of them would have been strong or weak. We have to take the weaker component, the weaker ion, which comes from the weaker part, and that only has to undergo hydrolyzation. You don't have to worry about Cl minus or whichever is the stronger component. You don't have to worry about it. Okay, fine. So there is something, again, I can write the equilibrium constant for this particular reaction which I wrote here. NH4 plus H2O gives NH3 plus, NH3 plus H3O plus, right? So that again, I'm going to give it a special name. It's going to be called KH, hydrolysis constant. Okay, H represents hydrolysis constant, right? So hydrolysis constant, I can write it will be NH3 plus concentration, H3O plus concentration, H2O I don't have to write, and it will be NH4 plus concentration. Okay, and I can do certain modifications to this reaction, modification to this equation, right? And I don't want to spend time on the derivation part. I'm just directly going to give you the formula. It's equal to Kw by Kb. Okay, Kw, I know what is the value, 10 to the power minus 14. Like, guys, don't get scared. How did Kw come here? Nothing. I already had H3O plus concentration, right? Now in the KH equation, I would have just multiplied and divided by OH minus. That's what I did, right? So they eventually would have had H3O plus into OH minus, and that I can write as Kw. That's what I did. Don't worry. Okay, so Kw, Kb is the Kb, in this case is an acidic salt. We are talking about the weak base is Kb. So the weak base was NH4OH, or say NH3. And guys, one more thing I want to tell you, this NH3 and NH4OH are same. Please don't confuse yourself. Now I can prove it to you if you want. So if you have NH3 and if you it dissolved in water, right? Okay, so obviously this is going to be a base, a Lowry Bronsted base, which is capable of accepting H plus. So this is going to give me H plus to this, right? So what will be there? I will have NH4 plus, and this would have lost H plus. So what will be remaining is OH minus. So NH4 plus OH minus will give me NH4OH. Okay, so either when I say ammonia or when I say ammonium hydroxide, it is going to mean the same. Right, in the questions also they'll be talking like that only, and mostly they'll be speaking only in terms of ammonia, not in terms of NH4OH. They'll be saying Kb of ammonia is so and so value. Okay, right. So this Kb, whatever I'm talking about, is coming from the weaker part. The weaker part in this case would have been NH4OH. Okay, they'll give you the value in the question. Don't worry. So this is about the hydrolysis constant. Hydrolysis constant for an acidic salt is equal to Kw by Kb. Okay, fine. Now let me get one more formula is there. That is my pH formula for an acidic salt. So pH will be 7 minus log of, am I doing it correctly? 7 minus log of salt. Wait. 7 minus, wait. Okay, guys, I don't want to tell you something wrong. Let me check. It's been long since I taught this chapter. Okay, no issues. Oh. 7 minus, 1 second guys. Sorry, it's taking a little time. 1 second. I don't want to tell you something wrong. That's why. 1 second. Oh. Okay, yeah, I got it. So what happens is the next thing we'll be studying about is buffer solutions. Okay, so I get confused between salt hydrolysis and buffer solutions. That's the point. Okay, so it will be 7 minus half into pKb plus log C. Okay, so obviously the pH should be less than 7. pKb is the pKf of the base, weak base, right? And C is the concentration of the salt, whatever the salt you have. Okay, so 7 minus half into pKb plus log C. So two formulas you have to remember. One is for the hydrolysis constant, and another is the pH value of the acidic salt. Okay, now when I go for basic salt, okay, let me actually make some page. Right, so when I go for a basic salt, right, so let me take CH3COONA. Right, so I know again only the weaker part is the one which will undergo hydrolysis. So it will be something like this: CH3COO minus plus H2O. Now you see, this is the CH3COOH would have been the acid. So CH3COO minus would have been the conjugate base of CH3COOH. Right, so basically this is going to act as a base. It is going to accept H plus from water. Right, okay, so how will you write the reaction now? This would have been CH3COOH plus, now this would be H2. I mean, if I removed H plus from this, it would have become OH minus, right? So again, I can write the KH for this. Now KH in this case will be equal to KW by Ka. Ka again is the weak acids Ka. That is the hydrolysis constant. Okay, now the next, the pH value, if you check, pH will be 7 plus half into pKb plus, okay, pKa, it's not pKb, pKa plus log C. Again, pKa is the weak acids pKa, right? And this C is the salt's concentration, the CH3COONA's concentration in this case particularly. Okay, so again, for two formulas for basic salt. Okay, right? So fine. So that's about the salt hydrolysis, people. To four formulas, one for acidic, I mean, two for acidic salt, two for basic salt, KH and pH. That's it, right? And what is the time? Okay, 8:32. So I just have buffer solutions alone. I just have to give you the formula and teach you what is buffer. Maybe I'll stop with this for today. Okay, so tomorrow I will just take 10 more minutes for me to complete buffer. Okay, so that I'll complete, and then we'll do some problems, and then we are done with ionic equilibrium also. Okay, and the next chapter I'll be starting would be gaseous state. Okay, ideal gas equation, that chapter. Okay, so don't think it's just ideal gas equation. There are a lot of stuffs there, right? I don't know whether you remember. You have diffusion, Graham's law of diffusion, RMS velocity, average velocity, this velocity, kinetic theory of gases. Even to some extent, we'll be studying about liquid state, critical temperatures, all these things, Okay, so you'll be studying in next class, not next class. That is like most probably will be on Monday. Okay, so anyways, we'll get the schedule about the new these things. Okay, fine. Thank you, guys. We'll meet again tomorrow.
Thank you, sir.
Thank you, sir.
Yes, sir.